Before jumping into the solution aspect, let us first get an understanding of the problem statement. As an input, we'll be receiving a matrix of heights in a m by n matrix, and on the top and the left edge we'll be having connection to the Pacific Ocean, and on the right and the bottom edge we will be having a connection to the Atlantic Ocean. The aim here is that we have to determine the flow of water from land to ocean, and the flow has to be such that the water flows from this landmass that we have into both the Pacific Ocean and the Atlantic Ocean, and this combination we have to figure out as a resultant 2D array and return. There are a few rules, of course, that we have to follow. One of the rules is that when water flows from one portion of the land to another, it can only flow if the next portion is lower than the previous portion. For example, what I mean to say is water can flow from 3 to 1 height because this portion is higher compared to this portion. So when we follow the convention, it has to be sure that for the water to flow from land into the ocean, the value here has to be higher in comparison to the value here. Otherwise, water will not be flowing in this direction. And having said that, first we will be seeing how the water flows only into the Pacific Ocean. So only into this and this edge we will figure out how the water is going to flow. Then we will figure out how the water flows only into the Atlantic Ocean. So on this side we will see how the water flows, and this for the right and the bottom edge. After we figure out for both these oceans how the water is going to flow, then we will get a combined result and take intersection of how the water will flow in both the Pacific and the Atlantic Ocean. And that's pretty much the problem statement. And to figure out how much water is going to flow in the Pacific Ocean, as we said, we are going to be doing a depth first search mechanism to figure out how the water will flow only into the Pacific Ocean. Let's see the matrix for Pacific Ocean itself. So what we will say is, first for Pacific Ocean we will see what the flow is going to be, and then we will see for the Atlantic Ocean. Now when we see the flow for the Pacific Ocean, we will start from the first row that we have with us. Let's start with this specific row that is given to us. What is the value that we have in the first row that is given to us? The value is 1. So I will start with 1 here, and I will move ahead with this 1 that I have. Now from this 1 that is given to us, how can we proceed ahead? We have another rule that needs to be followed, and the rule says that from a landmass to the next landmass, water can flow in all 4 directions. So it can flow towards the right, it can flow towards the left, it can flow towards the top, and it can flow towards the bottom, provided it's not the edge connected to the ocean itself. If it is connected to the ocean itself, then it's directly going to go into the ocean, and we are not going to consider that aspect. We have to first find the path within the landmass itself that will be flowing within the ocean, and this landmass has this heights that is given to us, which are represented by this matrix that we have with us. And let's say I will go in the right direction first. So I will go from here towards the right direction. Just before I go towards the right direction, I will maintain the current position that I have to make sure that I can reach this position. So at this point of time, I can say that I am able to reach this position, this being my starting point. I can reach this position with this cell being my starting point, and that is represented by 0, 0. This is the first entry I'm going to keep track of in my flow tracking for Pacific Ocean. I will maintain a set out of this, and this data of cells will keep going into my set. And I say I try to move in the right direction. Towards the right, I have a 2 with me. Is flow possible considering I am at this cell? So let's say I have a 1 and 2. The flow will be such that the neighboring cell has to have a higher value for it to then flow back into the ocean. What I mean to say that is, when the final flow gets computed, let's say I'm here. Now from here, for me to go here, this has to be having a height higher, because then the flow will be something like this into the ocean. And for that to work, the next cell that I am currently at has to have a value which is higher than the current cell. Only then it is possible for the flow to go into the ocean, because if this was lower, then it is not possible to flow. So it has to be either higher or equal to the same height. So if this was 1, then also it's valid, you can still have a flow. But if this is going to be 0, then the flow is not going to happen. And taking that into consideration, now what we will do is we put this first cell 0, 0. Then from there we went to the next cell. Flow is possible, all good. I will mark this as reachable. This position is 0th row and the first column, so it is 0, 1. Then I will move forward, again doing backtracking and depth first search. So depth first search is going to keep going down, keep drilling down towards the leaf node, and then it's going to come back. That's how this depth first search mechanism is traversing. So similarly, from 2, I will now go to the next one towards the right, which is also 2. So if the next one, so this one has to have a height which is greater than or equal to for then the flow to go into the ocean. And with that being equal here, the flow is also possible, and this gives us 0, 2. Similarly, I will go to the next one. I see a 3 here. Flow is possible from this to this because this is higher, so that then water can flow back into the ocean. And I will say 0, 3 will also go into the set. Then I will go from here to the next one, which is 5. 5 is greater, so the flow is going to also be possible. And then I'm going to put inside it 0, 4, that I can reach this point. Once I reach this point, I try to go towards the right. Now at this point, I am not able to go to the right because towards the right, I have the ocean. We only consider within the landmass at this point. And because of that, I stop here. I don't go any further. And now I will go towards the left. So first I kept on going towards the right. Then I will go to the left, and I will go to the top, and then I will come to the bottom. I will try to go to the top also and bottom also. But before that, I see left. Left, I have this one. I cannot go from here to here because the value here is less. The value has to be higher. So that's why I will say that I cannot go in the left direction. Then I will go towards the top. I have an ocean there. I will try to go to the bottom. Bottom, I see 4. 4 is having a value that is less. I have to have a height value which is higher for the water than to flow from this point into the ocean. And because of that, what we will say is it is not possible to go towards the down. And because of that, it doesn't go into my set. I backtrack from here. I don't go towards the back. I come back to my 3. Now again, from 3, I went to the right side. I will go to the left side now. On the left side, I have 2 here. Now this 2 is lower, so it's not going to be have a floor if I'm trying to go in this direction. If I'm going in this direction, then it is possible. In the opposite direction, it's not possible. Then I try to go on the top, it's ocean. I try to go on the bottom, I see a 4. This has a value higher, so then when the flow happens, it's going to be possible to go from here into the ocean directly. And that's why this is valid, it is reachable. And then I will just pick up the position that I have, which is going to be first row and the third column. So it's going to be 1, 3. And then from here, I will see again, I try to go to the right position. From here, I see on the right 4. It is equal, it is not less than, hence flow is possible. I will also take that into consideration with 1, 4. Next, from here, I try to go to the right. It's ocean, it's not possible. I try to come back, it's equal, but it is already in my set. I will go on the top. On the top, I see 5. Flow from here to here is possible because this is higher. I can go then from this to this. And because of that, I will also consider this one, which is 0, 4, but 0, 4 is already there in my set. And then it's already reached, so I don't have to again do the same traversals for it. I just come back. I try to go down, and down I see 1. 1 is lesser, so flow is not possible. I will not go in this direction. I will stop here. I will stop here. I will come back to my 4 now. I went into the right direction and then I went all the way up. Then I'll try to go to the left now. So when I go to the left, I will see 3. Flow is not possible because it's lower. The next cell has to have either equal or the same value. Otherwise, flow is not going to happen. And because of that, I will now try to see what is there on the top. On the top, I have 3 here, so flow is not possible anyways. Then I will go down, I will see 3 again. This is lower, so flow is not possible. Nothing happens here. I come back to my 3. Now from 3, I had gone down, I had gone towards the right. It's not possible to go on the top. And towards the left, I have this, which is already reached, and the value is also lower. And I backtrack from this point that I have. I come back to my 2. Now from this, I will see whether I can go towards the back. Yes, I can go towards the back, but that value, which is 0, 1, is already there in my set, so no need to go back. That is going to be a check there, which will say if it is there in my reachable set, then don't do DepthFirstSearch through that node again to avoid repetitions. And then I will only have one way to go, which is down, that is 3. 3 is going to have a value which is higher than my current value or equal, which is 3 is greater than that. So flow is possible. Because flow is possible, I can mark this as reachable. And then what will happen is, whatever the position I have, so this position is 1, 2, I will also put that in my set. Then from this position, I will see towards the right where I can go. So towards the right, I have this 4, which is greater, flow is possible, and this position is 1, 3 that I have. And 1, 3 is already there in my reachable set, so I'll just skip it. Then I will try to go in the next direction, because if it's there in the set, I don't do a DepthFirstSearch again. I will try to see on the left side what I have. I have a 2 here. This is lesser, flow is not possible. I don't explore that direction. Then I try to go to the bottom. I see a 5. 5 is greater, flow is possible. And because of that, I will say this point of 5 is reachable. This point is basically 2, 2. So I will say 2, 2 is reachable. And from here, then I will again say go towards the right. From here, right is 3. 3 is lesser, flow is not possible. It has to be equal to or greater. I try to go towards the left. We have 4 on the left side. 4 is lesser, flow is not possible. Then I try to go on the top. Top is already reached, so I have to skip that. Towards the bottom, I have a 1, which is here. And because 1 is lesser, flow is not possible. And that's pretty much it. I will backtrack again to my 3, and then I will try to go in the forward direction. So I went to the down now, and I will just backtrack. Now from 2 I had gone down. I have already explored top, it is not possible. I went to the right, and now I just come back to my original 2. Now from here I will see backtracking to the back is not possible because I've already reached this. On the top it's not possible. On the bottom I see a 2 here, it's possible, flow can be possible. And because of that I will say I will try to put 1, 2 in my, so this is going to be 1, 1, and it will say 1, 1. It will go in my set. After this I will see whether I can go towards the right. Yes, I can go towards the right, but this right, which is 1, 2, is already there in my set. So I stop there. Then I see whether it is possible to go on the left. Left I have 3. 3 is going to be 1, 0. 1, 0 doesn't exist in my set. So I will say put 1, 0 in my set, and from here then I will see towards the right it is not possible because that's the way I came from. I will try to go towards left. I have ocean here. Towards the top the value is lower, flow is not possible. Towards the bottom the value is 2, flow is again not possible. So I will just pick this up and stop, and I will come back to 2 now. I will see whether it is possible to go down. To go down the value is higher, it is possible to reach here. This point is 2, 1, and 2, 1 is going to now go in my set that I have. And then from here I will see whether it's possible to go towards the right. It is possible. This value, which is going to be 2, 2, is already in my set. So I skip this depth first search. Then I go towards the left. I see a 2 here. 2 is lower, flow is not possible. Then I try to go to the bottom. I see a 7 here. Now 7 is greater, flow is possible, and because flow is possible I can say that this value, which is going to be 3, 1, can be put in my set. From this I will see whether it is possible to go towards the right now. The right side we have 1, that is this 1, flow is not possible. Then I will see bottom also we have 1, flow is not possible. Left we have 6, it is lower, flow is not possible, and top we have already visited. So this is the highest point that we can have, and so I just put that value, which is going to be 3, 1, and I backtrack. I backtrack to my 4 here. Then I try to go towards the right side, which has 5. This 5 is having a value of 2, 2, which we previously visited, and then we decided we won't go in that direction. We also said on this side we have a 2 here, which is lower, flow is not possible. On the top side we have already visited in my previous iteration, and this value, which is going to be 1, 2, already exists. I just backtrack from here. I go to my 2 now. Now from here I again see backtracking because I went on the right direction. I went in this direction. I also went in the left direction. Now in the left direction I have my 3. This has a value which is higher, so flow is possible. This value 1, 0, which we have, already exists. This is also just going to get skipped now. I go back to my previous value. Now from here I have gone towards the right. I cannot go on the top. I have gone to the bottom. At the left side I have already considered, and I backtrack from here. I come back to this one. I had explored the right side completely. Now I will see whether it's possible to explore the right side, which is not possible because it's the ocean. On the top side it is also not possible because there also we have ocean. And then we explore the bottom side. So from here we will say go here. Here we have 3, flow is possible, and that value, which is 1, 1, already exists. So we just stop here. So from this first iteration, wherein we covered the entire first row that we have, we were able to find these unique points within the matrix that we have, wherein the flow is possible. And after this, what we will do is similarly traverse the other side. So one side that we had was this specific ocean side, which we traversed with this path with traversal of all the columns in the first row that we had. Now we will also traverse this side similarly with all the rows we have in the first column. We will now traverse this whole path that we are given, and we will start with the first value that we have, which is going to be 1. Now this one has already been traversed when we traverse towards the first row that we had, and then we can just skip it. We can just move forward to the next one, which is 3. Now this 3 that we have with us is going to work something like this. Again, I will say go towards the right. So I will say on the right side we have a 2. 2 is lower, flow is not possible. It has to be higher for the flow to be possible. Towards the left we have ocean, flow is not possible again. Towards the bottom we have a 2 here, so flow is not possible, and that's pretty much it. So this point we say is reachable. This point is 1, 1. 1, 1 already exists, and we just move forward to the next one because all the other values have lower heights in comparison. Then from 3 we go to 2. Now this 2 that we have, again we will say let's try to go towards the right. On the right we have a 4. So 4 having a higher height value, it means the flow is possible. Flow is possible in the sense that from this flow of this cell having a value of 4, you will have a flow that goes into the ocean because it will go from a higher height to a low height then. And because of that we can say this value, which is 2, 1, can be put in my set, but it already exists or not, that is something we have to first check. And this point is going to be value of 2, 1, and 2, 1 is already there in my set, so I just skip this. Then I try to go towards the left. It is the ocean, not possible. Then I try to go on the top. We have this value, which is 1, 1, that it comes to 3. 1, 1 is already there in my set, so I skip there again. From here then I try to go to the bottom. Bottom value is 6. 6 is greater than 2. With this value, that point is reachable, and this point is 0 is reachable, and it is not there in the set. From this point we again try to go towards the right. We have 7 here. 7 is having a value higher, flow is possible, it is reachable. The value 3, 1 is there in my set, so I don't go in that direction. Towards the left I have the ocean. Towards the bottom I have 5. 5 is having a value which is lower than the current height, so flow is not possible. So I will just backtrack from this point now. So I went towards the top, right, bottom and the left, and then I will move forward to my next value, which is 6. Now from here I will again say try to go towards the right, flow is possible, and this value is 3, 1. 3, 1 already exists in my set because this is repetitive now. Then I will try to go to the bottom. I have my 5. 5 value is lower, flow is not possible. Towards the right we have the value 7. Towards the left it is the ocean, so it is not possible. On the top we have 2, which is already visited, so I just have marked this 3, 1 as visited, and I move forward to my next one. My next one is 5. From here I will again say, is it possible to go towards the right? Right value is 1. 1 is not higher, flow is not possible. Is it possible to go on the top? Yes, it is possible, but this value, which is going to be 3, 0, is already there in my set, so I cannot again go there because that will be duplication of depth first search traversals. And towards the left I have my ocean, so it's not possible to go on the left also, and this pretty much freezes the flow. Now the next step is whatever points we have received, let's mark them. 0, 0 is this point, 0, 1 is this point, 0, 2, 0, 3, 0, 4, 1, 3, which is going to be this point, 1, 4, which is going to be this point, 1, 2, which is this, 2, 2, which is going to be this, 1, 1, which is going to be this point, 1, 0 here, 2, 1 goes here, 3, 1 goes here, 3, 0 goes here. And this is the flow that is possible into the Pacific Ocean. I will just highlight it a bit more here so that it becomes very clear as to how the flow is possible. And with this, we can say the flow will be possible in the Pacific Ocean with the data that we have. And for the last value also that we had, I can say that when I try to traverse phi, I have to also mark phi as reachable, because when I was doing depth first search, I was able to reach phi. So this value, which is going to be 4,0, is also supposed to be considered. And then I will just mark this value. That's going to look something like this. This is how the final path of flow is going to be looking. Let's do the exact same thing for the Atlantic Ocean flow as well. But in this case, instead of starting from the top row, we will start with the bottom row that we have. So we will have this one, and from this then we will go towards the right side, which is going to be this entire column. But first we will go from here, because in the previous case for the Pacific one we started from here. For Atlantic we will start from here. And when we start from the bottom, we will see we have 1 here. So 1 is reachable, and the position here is 4,0. So I will say 4,0 is reachable. Then I will go towards the right. On the right side that I have, I will see that the value that exists is 1. The value on the right side is lower than the current value. Flow is not going to be possible. So I will not go on the right side. Then I will try to go towards the left. On the left I have the ocean. It is not possible to go towards the left also. Towards the bottom also we have the ocean. So it is not possible, and that's why from here it is only possible to go on the top. On the top we have a 6 here. 6 being a higher value, that means flow is possible. And because flow is possible, what we will say is that also consider this one, which is going to be 3,0. I will say 3,0, and this 3,0 then will again try to go in a depth first search manner. Keep on going deeper as much as possible. Go on the right. On the right side I see a 7. Now 7 is higher, flow is possible. And because flow is possible, what we will say is also consider this value, that is going to be 3,1. So we have 3,1 here. From here again go deeper towards the right. We have 1 is lower, flow is not possible. You come back, you see, try to go towards the top, value is 4 is lower, it's not possible. Try to go down, it's 1, value is lower, flow is not possible. And you just backtrack from this point back to my 6. This side it's not possible. Bottom we already came from there. On the top we have a 2 is lower, flow is again not possible. So you stop right there, and from 6 then you backtrack. And that's pretty much it for the first iteration that we have with us. Then we move on to the second iteration. We have a 1 here. Let's try to go towards the right, but before that we have to mark this as reachable, and this point is going to be nothing but 4,1. I will say 4,1 goes in my set for Atlantic Ocean now. And towards the back side I have already visited. This is going to be having a higher value. It is possible to have a flow, but value 4,0 already being in the set, we don't go towards the back. Then we try go on the top. We have 7. Flow is possible. Flow is possible, but this value 7, which is having 3,1, is already in my set. So I am not going to go on that side also. I'll just stop. I move forward to my next one, which is also 1. From here I will say try to go to my 2. Before that, just put this in my set because it is reachable. And the value is going to be 4,2. And this 4,2 goes in my set now. It's possible to go towards the right. The right value is going to be 4,3 that we have. I will say 4,3. Now this 4,3 value which I have put from here also, I will again try to see whether it's possible to go towards the right. On the right I have 4. 4 flow is possible because 4 is higher than 2, and because it is possible it will also go in my set. So and the value is going to be 4 comma 4. And then I try to go towards the right again. I try to see in the right side, and then I see I hit the ocean here, so it's not possible to go towards the right anymore. Towards the left I have the point I have already come from, which is already in my set here, so it is not valid case to do a depth first search again. I will try to go on the bottom. Bottom is the ocean, I cannot go in that direction. Then I will try to go on the top here, which is 5. Now 5 is having a higher value, that would mean that flow is possible, and this value 3 comma 4 is supposed to now be reachable. Now from here I will again try to go towards the right. It is the ocean, it's not possible. Towards the left I will see I have 4, the value is lower, flow is not possible, so right left is not possible. I try to go on the top, value is 1, 1 is lower, flow is not possible, so I just stop and backtrack. I come back to my 4, and then I come back to my 2 again. I will see on the left side it is not possible because that's where I came from. On the top side I see a 4 here. 4 is having a value which is higher, so flow is possible. 3 comma 3 position is also supposed to now go in my set. From here I will try to go towards the right. Right, it is 3 comma 4. 3 comma 4 already exists, so it's no valid use case to go to the right. I will try to go on the top. Top I have 3 here, so it is not possible to go towards the top also because the value is lower. On the left the value is 1, so it is not possible on the left side as well. Hence I just backtrack. I come back to my 2 that I have, and that's pretty much it. I come back to my 1, and from 1 I will try to go on the top. On the top I see 1. 1 is having a value which is equal or greater, which is 1, and 3 comma 2 is something that doesn't exist in the set yet, so I will put 3 comma 2 in the set. And then from here I will say, okay, let's try to go towards the right. Right I have 3 comma 3. 3 comma 3 already exists, not possible. I will try to go towards the left. We have 7. 7 is 3 comma 1. 3 comma 1 already exists in my map, so I cannot go in that direction. I will try to go on the top. I have top 2 comma 2 value. 2 comma 2 doesn't exist in my set, and it is having a higher value, so flow is possible. Hence I will say 2 comma 2. Now from this I will try to go towards the right. I have 3, flow is not possible. Towards the left I have 4, flow is not again possible. Towards the bottom is where I came from. Towards the top I have 3, flow is again not possible. So I just stop here. I put my 5 as 2 comma 2. I come back, and towards the right I see I have a 4. It is having a value of 3 comma 3, which is already there, and hence I will just backtrack back to my 1. Now I will have 2 here, which is the next one. So this is going to be 4 comma 3. Now this 4 comma 3 is something that is already there in the map that I have here. So I will try to go towards the right. I see 4 comma 4 already exists. I will skip this side, and this 4 comma 3 value on the top has 4, flow is possible, but 3 comma 3 already exists in my set. I will not go in that direction. Towards the left I have 1, flow is not possible because 1 is lower than 2. And then I move over to my next one, which is 4. From here I will say 4 comma 4 already exists in my set, so no need to put it again. I will go on the right side. I have the ocean. On the top I have 5. 5 is 3 comma 4. 3 comma 4 already exists, so I am not going to go in that direction as well. Towards the left is I am having 2. 2 is lower, flow is not possible, and that's pretty much it. I have already put it in my set, and the transaction ends. Now that I have covered the lower row, I will go to the last column, because that's where these are the two components where the Atlantic Ocean lies: the last row and the last column. And similarly I will do depth first search here as well. We will start from 5. I will again go from 5 towards the right. It is hitting the ocean. It is not possible to go any further on the right side. I will try to go towards the left. The value is 3, which is lower. On the top I have hit the ocean, and the bottom I have hit 4. And And this value, which is going to be 0,4, is already being traversed and part of the set. Then I go to my next value, which is 4. I try to go towards the right. I've hit the ocean. I go on the top. 0,4 already exists, so I cannot go on the top. Left side I see 1,3. 1,3 is having equal value, so it is possible to also have 1,3 in that map, and hence I pick it up. From his value, then I will try to see whether it's going to possible to go towards the left. I have 3 here. Flow is not possible. I will see whether it's going to possible to go down. 3 not again possible. On the top I also have 3. Flow is not possible because 3 is still lower. So I come back to my 4. I went in the left direction. I went in the top direction. I try to go now in the bottom direction. I have 1. 1 is lower. Flow is not possible. And that's pretty much it for the value that is 1,4. And 1,4 I will first see if it exists. If it doesn't exist, it's going to go in my set. Then I will move forward to the next one, which is going to be my 1. I try to go towards the right. I hit the ocean. I try to go on the top. I hit 4, which is going to be 1,4, already exists in my set. I can just ignore it. Towards the left I see my 3. 3 is going to have a value of 2,3. 2,3 is something that we will first check if it exists in the map I am tracking or not. So 2,3 doesn't exist, so I will say 2,3, you put it in this map. Then from here I will try to say it is possible to go towards the left, and towards the left I have at this value 5, which is having a high value, so flow is possible. I will see is 2,2 existing in my map. Yes, 2,2 exists in the map, and because 2,2 exists in the map, I will say that I am not going to go in this direction. And then I will say whether it is possible to go on the top. Top is 1,3. 1,3 is something that already exists. And then I backtrack. At the bottom I have 4. 4 is something called as 3,3, which is already existing as well. I backtrack to my 1. 1 is something having value of 2,4. 2,4 is something that will now go in my set. Then I move forward to 5. 5 I will say again go towards the right. I've hit the ocean. Go towards the top. I've hit 1. 1 is having a lower value, so flow is not possible. Towards the left I have 4. Flow is not possible again. Towards the bottom also 4. Flow is not possible. Just keep track of this 3,4 and move forward. Then I've hit my last value, which is 4. 4 is something 4,4, which already exists. Then on the right I've hit the ocean. On the top I have it 5. 5 is 3,4. 3,4 already exists in the set, so I cannot go in that direction. If I try to go towards the bottom, I hit the ocean. Towards the left I see 2. 2 is lower, so flow is not possible. So I have just put 4,4 in my map, which already exists, and that's pretty much it. This just covers it up. Now I will just populate the matrix again with the values that we have for the flow. So first value is 4,0, then value is 3,0, then 3,1, then 4,1, which is this one, 4,2, which is this one, 4,3, which is this one, 4,4, which is this one, 3,4, which is this one, 3,3, which is this one, 3,2, which is this one, again 2,2, which is going to be this one, 0,4, 0,4 is this one, 1,3, which is going to be this one, 1,4, this one, 2,3, which is this one, and 2,4, which is this one, and 3,4, which is already filled. And with this I will just mark this a bit better so that it gets highlighted clearly. And then this goes from here to here, and then this goes from here to here, and then this is something that gets filled. We have covered the depth first search traversals for both the Atlantic Ocean water flow and the Pacific Ocean water flow. Now let's combine these two into one and see what do we get. We will just intersect both of them into the Atlantic Ocean. We will see the topmost point here. So this value is going to be 0, 0, 0,4. So this value is going to be 0,4. I will just mark this point here as highlighted. I can also see here the point exists in the second matrix. Then I will come down. I will also mark in the second matrix because it exists in both the matrix. Then I go down, third one doesn't exist, fourth one doesn't exist, fifth one also doesn't exist in both of them. I will move on to the next one. I will see 3. This point doesn't exist in both of them. The next point, however, exists in both of them. So I will mark that next point. And after that, this points and this points are not intersecting. I will go to this point, which exists in both. After that, these points are not overlapping. I will go to the next point, which is here. It overlaps in this one. And then I will go to the last point here, which is also intersecting, and this point, which is also intersecting. So these 2 points intersect, leading us to have this intersection that can now be written over our main map that we have. So I will say these 2 points that I have with me, then another point here, then another point just above it, and then another point just above it, just 4, and then this 2 points that I have with me. So I have now combined the value from both the values that were provided, that is the Pacific Ocean and the Atlantic Ocean, and this outcome that I have received shows me after intersection of both the points from both the oceans, I am saying that this is the point of intersection wherein the water flows into both the Pacific Ocean and the Atlantic Ocean. Let's convert whatever we covered so far into code. We said we will be maintaining a set for the Atlantic Ocean and we will also be maintaining a set for the Pacific Ocean. And to do that, I will just say let the Pacific Ocean reachable set be a value. Then for the Atlantic Ocean also I will say keep a set so that I can track for Atlantic Ocean what values are reachable. Then in the end I'm going to have a result. This result is something that we return in the end, that is going to consist of all the points in the matrix, points being cells represented by row comma column that will be flowing into both the oceans. And in the end I will just return this combination of intersection. Then I will say I'm going to have my DepthFirstSearch recursive function that is going to take a row and a column and a ocean that we are currently going through, because we will go for both the Atlantic Ocean and the Pacific Ocean through this DepthFirstSearch traversal mechanism. And then I've also said we will cover the topmost column, the bottommost column, the leftmost. Then we also said we will be covering the topmost row, the bottommost row, the leftmost column and the rightmost column that we have with us in both the oceans accordingly. So for the Pacific Ocean that we are given, we will be covering the topmost row and the first column, while for the Atlantic Ocean we will be covering the rightmost column and the bottommost row. And to do that we can just do something like this. I will go from all the rows that I have, and that length can be picked out from the heights matrix that we have received. So whatever the length is going to be the length of my rows. I will go through all my rows and I will also go through all my columns. So I will say columns is going to be heights of 0. Just pick any row dot length, and this is going to be my length of my columns. And to do that I will just go through again all my columns. When I go through my rows, I have to make sure that I go through the topmost column and the bottommost column that I have. The topmost column being the first column and the bottom column being this column. So both this column for the Atlantic Ocean, the rightmost, and for the Pacific Ocean, the leftmost. And to do that, I will just go through the columns. I am going to call this DFS with row and column, and with row being having a value that changes, first go through the 0th column that I have. The 0th column is this one. And to go to that one, I will just say pass as 0. And then I will say I also want to go through the last column. The last column is basically this column's value dot -1, because this value is going to be the last column. Now, when it is the Pacific Ocean, we want to go through the first itself, only for the Pacific Ocean. And because of that, I will just pass the first column for the Pacific one, and for Atlantic, we want to go through the last column that we have with us. And for Atlantic, I will pass the last column. This will cover the respective cases of one side. Then for the next side, I will just say instead of rows, use columns, and the value that is iterable now is going to be I, that I will go after the row. And similarly here also, I will just go after the rows now, and instead of columns, I will just say rows. So it will cover the first row for the Pacific Ocean, which is going to be this one, and it's going to cover the last row for the Atlantic Ocean, which is going to be this one, which is what we want. And in the end, I want to perform a intersection of this two. And to perform this intersection, I can just say go from I up to the length of the rows that you have, and then use a nested loop for j. J will go up to the number of columns that we have with this nested loop. And let's say the time complexity for rows is going to be big O of m, and for time complexity related to the columns be big O of n, because this is a m by n matrix. Then the time complexity for both of this in combination will be big O of m into n as a combination. And in this now, I will say if it exists in both the sets. So first we found an intersection between both the sets that we had, and then only we said it can flow into both the oceans. So if within the Pacific Ocean set that you have, because the set you just do has what? You try to see it has I, comma, j combination, something like this. And it also has in the other ocean, then you can say it exists in flow of both the oceans. And the other ocean being the Atlantic Ocean, I will just say Atlantic Ocean also has this specific cell. Then I can just push the value in my result. So I will just say result.push I comma j, and then in the end I'm just going to return my result. And that's what we did basically in our example. We found the interaction, and then intersection was returned. Now comes the tricky part of doing depth first search traversals. Now this depth first search traversal that we are going to be doing is going to be dependent on the current cell that you have reached. As soon as you reach the current cell, you have to put it as reachable in the corresponding ocean. And to do that, I will just say ocean reach dot add whatever row that I have, whatever column that I have, combination, which is going to be then compared in this format at the end. I will just say instead of j, it's this and this one. And as soon as you reach the point, you just add it to your corresponding ocean. Then for all the directions, like you can go on the top, bottom, right, left. Then let's just keep a track of all the directions that we can possibly have. I will just say constant directions is going to be an array of, first I can go towards the right. The combination being received is row, comma, column. To go to the right, I have to go in the next column but stay in the same row itself. So I will just say 0, comma, +1, I go to the right. Then I will go to the left, I will say 0, comma, -1. So this goes in the right and the left direction. Now to go to the top, I have to go to the previous row that I have but stay in the same column, and similarly to go to the bottom I have to go to the next row but stay in the same column that I have. And for all the values I can just say let the next row and the next column of the directions that are possible do a depth first search, and doing depth first search will just pass the next column and the next row that we have with us along with the corresponding ocean that is being traced. And before doing this now, we will make sure that we are ensuring that the traversal happens within the bounds of the matrix, because if you hit ocean on any side, you don't traverse further in that direction. And what do we mean by bounds of the specific matrix? So if the row that you are supposed to go to is outside the bounds, which is less than 0, or the row is greater than equal to the length of the rows that you have received, you hit the upper bound, then also you can say it is out of bounds. Or if the next column that you are supposed to go is less than 0, or the next column is greater than or equal to the length of the columns that you have, that also means you have hit the bounds for that one, and then you just have to exit. And to exit I will just say continue. So in this case we continue. Also we want to avoid duplicate traversals of the same nodes, and to do that I can just say if my ocean already has that specific node which is supposed to be the next node, then I will just say you just skip it and move on to the next one, and this will look something like this. So for here it is dollar here, dollar this one, and dollar this one, and then I will just mark this as continue. Or if the last part that needs to be taken into consideration is the height aspect, you can only go to the next one if the next one has a height greater than or equal to the current one for the water to flow on the landmass. When if it's ocean just water can just flow, it doesn't care about the height. And to do that I will just compare from the heights matrix that I have received. So the height of the next row and next column that you are supposed to go, if it is less than the height of your current row and column, that will also mean that you cannot go in that direction, and you just skip that specific direction while you are going through. Next rows and next columns are going to be relative values. What does that mean? That means that to the current row that you add, you are going to add the next row and the next column that is supposed to be there. And because of that, what we will now do is say something like this: constant next row relative. So next relative row. Now the next row and the next columns that we are going to be tracing are going to be relative to my current row and my current column, which is going to be this and this. So it's incorrect to directly just compare the bounds with plus and minus. We have to take a relative value now. I will say let relative next row is going to be my current row plus my next row, and similarly my relative next column is going to be my col plus my next column. And with these values, then I check the upper bounds that I have and the lower bounds that I'm supposed to have. So this lower bounds and upper bounds, and similarly the next row and the next column which is supposed to be relative, and similarly the next column and the next row here also are supposed to be relative. And then you take the next relative row and the next relative column and try to reach a solution. And that's pretty much it in terms of the implementation aspect that is involved here. Now we said that the time complexity involved here is going to be big O of m plus m into n. This is big O of m, this is big O of n, big O of m plus big O of n plus big O of m into n, and this being the relatively very higher value, we just say that this is going to be the time complexity big O of m into n, because if you pass m here and this is just going to be following the same trace here. So the time complexity of this one is going to be the number of rows into number of columns that you have when this depth first search traversal happens. And the time complexity here can be represented as big O of m into n. And that's the complexity that gets applied to this overall loop as well. And the space complexity is also going to be big O of m into n, because the space complexity that gets applied to this one is m into n, because that's how the space being occupied by the call stack during depth first search works. The amount of space that is going to be utilized is going to be the amount of calls that happen through this depth first search, number of time it is getting called, which is going to be m into n, because for the rows and columns we go into a m by n matrix, and the call stack occupies that passage space for each call in the worst case. And that's why the space complexity will also be big O of m into n. And then the overall complexities and space complexity is going to be the value of big O of m into n. And that's pretty much it in terms of implementation. So it looks something like this in the end. Thank you for watching. Please like and subscribe.